Find the percent composition of each element in the compound Na2CO3. So this example is exactly the same as the percent composition 1 example. It's just this is a bigger compound. So we'll see that the steps remain the exact same here, and it's really no harder than before. So we'll list out the compound or the elements that we have in this compound. We have sodium, we have carbon, and we have oxygen. And so we'll look up their atomic masses on the periodic table. Sodium is still 22.99 AMU. Carbon we look up is 12.01 AMU. And oxygen, depending on your periodic table, 15.99 or 16, just because it's easier to use here. And there we basically have each element's mass there. Now we need to multiply by what the subscripts tell us so that we know how much sodium we actually have. In this case we have 2 of them. Carbons we just have the 1, and oxygens we have 3. So we'll work out those numbers so that we know how much of each that we have, or what the weight of 2 of them and 1 of them and 3 of them will be. And so we multiply this together, we get 45.98 AMU. 1 times 12.01 is just 12.01, and 3 times 16 is 48 AMU. And so now we know how much each piece of this compound weighs. To figure out what's going to be on the bottom of our fraction, we need to know the total mass of the entire compound. So if we add those all up, we find we get 105.99 AMU, which would be the mass of Na2CO3. To find the percent of each, we take the mass of the sodium and divide it by the mass of the total compound. So it's not going to be 22.99 in this case because there's 2 of them. We use the 45.98 all divided by the total, times that by 100, and we get 43.38%. To do the carbon, we do the exact same thing. Because there is only 1 this time, we can use the 12.01, which we would have read right off the periodic table. Again, we divide it by the mass of the total compound, and we get 11.33%. And lastly, we will do the percent for oxygen, which is going to be 48. Again, all over 105.99 times 100. And we get 45.29%. And as a double check, we should just see if this adds up to 100. And it does come pretty close, if not exactly 100%. So we know we've done it right.